students, it's Miss Culver. How you doing today? Today we're going to do notes on 7.3 called logarithmic functions, or we just simplify it to log functions. Logarithmic functions are the inverse of exponential functions, which explains why we are studying that now. In 7.1, we studied exponential functions. In 7.2, we studied inverse functions. And now in 7.3, we are studying the inverse of exponential functions, which is log functions. So you can take a minute to pause this video and fill in the notes that you already see. And I'm going to go over those now. So our lesson objectives, what we're going to do is write equivalent forms for exponential and logarithmic functions and graph them. In other words, we are going to be able to switch between exponential and log functions. A logarithm is just an exponent. That's all it is. It is another name for an exponent. Just like we have a lot of names for dogs, right? We call them dogs. We call them hounds. We call them pooches. We call them puppies. And so a logarithm is simply an exponent. And it's an exponent to any base. Now, a common logarithm would be a log that occurs commonly, and that would be a base of 10. So an exponent with a base of 10, because we use a base of 10 a lot. We use that in our decimal system. You saw that in scientific notation. And let's go ahead and look on the calculator where that is. So on your calculator, when you look down on the left-hand side, there's an LOG button. And when you hit that button, that means you are doing a logarithm with a base of 10. If you look above that button, you can see in blue it says 10 to the x, verifying again that your base is 10. A logarithmic function is the inverse of an exponential function, and it is so important on its own. It's not just the inverse of an exponential function. It is used for pH scales in science, for decibel levels, for noise, for Richter scale, for earthquake, measuring earthquakes, and so much more than that. It actually, your memory works as a logarithmic function, and some of your physical functions also take a logarithmic form. So we're going to take a look at some properties of logarithms, and so we are actually going to fill in the middle first, and then the left, and then the right. So we're used to exponential form. That's why we're starting with the middle. So let's say your exponential form is a base of b to the first power. And we know that that equals b. So how do we write that in log form? So we're going to go to the left here. The way we would write this in logarithmic form, notice we have 1, 2, 3 pieces of information. To write log of base b, we simply start with the word log, the abbreviation log, and then notice our base is b, and so we put the base below because that's where bases go. And then the solution goes right next to level with the log, and then we put an equal sign and we put the exponent, which in our problem was 1. So remember, a log is an exponent, and this says that the log equals 1. So again, base, exponent, solution. To write it as a log, you write log, base, solution equals 1. And the way you say this is log base b of b is 1. So let's do an example of that. Log base 2 of 2 equals 1. Log base 2 of 2 equals 1. Let's take our 3 items, 1, 2, 3. This is seen in exponential form when the base is 2 and the exponent is 1, the solution is 2. Notice that is true. Let's do the next line. We know that any base to the 0 power is 1. We've already studied that. Let's go to the left and let's write it as a logarithm. We have 1, 2, 3 items to place. So we start with log. The base goes below. The solution goes next to the log equals, and the exponent goes last. Again, notice this says that the log equals 0, and it is. The exponent is 0. You say this log base b of 1 is 0. So let's do an example of that. Log base 3 of 1 equals 0. Notice that this is true. When your base is 3 and your exponent is 0, the solution is 1. Now these all work for bases cannot be 1 because then you don't see any growth or decay. If the base equals 10, then that is the common log. And we showed that button on your calculator. The log can be any real number, and then it says let's do flashcards together. We are going to do that in class. Let's go to the next page. The next page in your notes actually says no need to do. So that's really nice. We do not need that. Let's move along. Let's try some problems. Let's see. Here we go. Now again, when you look at the top of this paper, I really believe that most of what you see, you can use if you need to, but we just really need to work on the examples below. But again, let's take a look where I circled here. The way you say this is log base b of a is x. Okay, let's go below. What we're going to do is we have an exponential equation and with 3 pieces, 1, 2, 3, and we are just going to write that in logarithmic form. So, number 1, 7 squared equals 49. Notice the base is 7, x is the exponent is 2, and the solution is a equals 49. So they're asking that we write this in log form. Here we go. We start with the word log. Log, and the base 7 goes below of the solution equals the exponent. There we go. Log base 7 of 49 is 2. We placed our base, our exponent, and solution in the proper logarithmic form. Let's go to 6 cubed equals 216. That is absolutely true. My base is 6. My exponent is 3. My solution is 216. Let's put that in proper logarithmic form. Log base 6 of 216 is 3. Base solution exponent. Let's try again with 2 to the 5th equals 32. That is actually true. And let's try it without putting in b, x, and a. My base is 2, my exponent is 5, my solution is 32. Let's go ahead and write that log. The base is 2, the solution is 32, and that equals the exponent. Now let's go back. Let's take logarithmic form and put it in exponential form. So let's take a look here. Log base 9 of 729 is 3. This is a true statement. The base is 9, the exponent is 3, and the solution is 729. Let's place our 3 items in exponential form. The base goes first, 9 to the exponent of 3 equals 729. We wrote our logarithmic equation in exponential form, and it's a true statement. Next, number 5, log base 2 of 64 is 6. This is a true statement. The base is 2, I can see the exponent is 6 and the solution is 64. Let's write that in exponential form. When the base is 2 and the exponent is 6, the solution is 64. Let's do one more. Notice though that it feels like I only have 2 items. A 1000 for a solution and a 3 for an exponent, but I don't see the base. When you don't see a base, that means it's a common log with a base of 10. So I'm going to go ahead and put that there to remind myself. And now I'm going to write it in exponential form. With a base of 10 and the exponent is 3, your solution is 1000. So again, if you see log without a base, the base is 10. Last page. Let's graph some logarithmic functions. So again, notice that at the top there's a lot going on here. We learned in 7.2 that if one function and another are inverses of each other, they will be symmetric over the y equals x line. And that's why you see this y equals x line here. Okay, so we're going to use our calculator to do this. Let's complete the tables. So 4 to the x is an exponential function. Where's my a? There really is a 1 out front. 1 times 4 to the x. And what we're going to do in red is complete the table. So notice all they're doing is they give you different x's across the top, and you put them into the function, and it produces the value below. So I am going to use my calculator if I have to, but I'm not so sure I need to. In your calculator, when you do 4 to the negative 2, you get a 1/16. 4 to the negative 1 is 1/4. Now, let's put a 0 in. 4 to the 0, oh, I know that answer. Anything to the 0 power is 1. Let's put in a 1 for x. 4 to the first, oh, I know that answer too. That's 4. Let's put, lastly, a 2 in for the x. 4 squared is not 8, it's 4 times 4, which is 16. Let's go ahead and graph these points. Here's my xy point, xy, xy. Let's graph negative 2 and 1/16. Here's negative 2 and 1/16. There we go, is really close to the x-axis. Let's graph negative 1 and 1/4. Again, just a little further up. Let's graph the point 0, 1, the point 1/4, and the point 2/16. Wow, that's way up there. And I'm going to connect these points with a curve. And you knew that this graph was going to take a curve because it's an exponential function. You also knew it was going to be increasing as you went to the right, like you see, because your base is 4. And anytime the base is bigger than 1, the function is going to increase. Now let's do log base 4 of x. I am going to use the calculator for this. You do have a log base button on your calculator, and if you do not in the classroom, we will make sure that you have one. Plenty of them do. So how do you put this function into your calculator? Here we go. Here's the calculator here. And the way that you get log base is you hit your math button. That is third on the left. And let's go over to number. That's 1 over at the top. And we're just going to cursor down until we see log base. I really thought it was there. That's fabulous. Let's go. Hey, this happens sometimes. Let's go back. Let's quit. Let's do the math button. Math. And it must be under the math button. I guess I didn't need to move over to number. Let's go down. Let's look for log base. Sorry about that. There it is. It's on A. Okay, so I'm going to hit this button, and log base 4 is what the problem says. And where my x is, Notice I'm going to put in a 1/16 like they did. Here's my x's, they're saying to put in a 1/16. So I'm just going to put 1 divided by 16, and that answer is -2. When we are together, we'll talk about why is the answer -2. Let's go back and put a 1/4 in for the x. So math, I'm going to go to log base. The base is 4. My solution is 1/4. Again, the base is 4, the solution is 1/4. The log is the exponent. So when I hit enter on the calculator, that's what it's giving me, is the exponent when the base is 4. So that's a -1. Okay, now they're asking us to look above, right? Notice they use the 1/16, the 1/4. Now we're going to use the f of x equals 1, f of x equals 4, and f of x equals 16. Remember, these are inverse functions, so for my 4 to the x, my exponential function, here's my x's, here's my y's, and because log base 4 of x is the inverse, we are switching the x and the y's. So I took all my y's and made them x's. Right, and now, all I have to do is look above on my in my chart, and I can just flip the points. So instead of 0, 1, I have 1, 0. Instead of 1, 4, I have 4, 1. And instead of 2, 16, I have 16, 2. But let's just check. Is that true? If I use the calculator with an x of 1, do I really get a 0 out? Let's check it. Log base 4 of 1. Let's see if we get a 0. Log base 4, and our x is a 1, and we should get a 0, and we do. Great, just checking. Let's go ahead and graph. I'm going to graph the point 1/16 and -2. Just eyeballing that. 1/4 and a -1. 1, 0. 4, 1, and 16, 2. And when you put a smooth curve through those blue points, you have your function, and you can see these functions, the exponential and the logarithmic, are symmetric over the y equals x line. If I folded my paper on this y equals x line, these two blue and red graphs would match up. Thanks for hanging out with me today, and have a great day.